This model will demonstrate the effect of using proper and improper vibration mounts under a machine. This motor has no output shaft, but it has an internal counterweight that gives it quite a large unbalance. We have a 12-pound block of steel to which the motor is attached. I'll turn the motor on and we can see it's got a bad balance problem. Now the casual observer might be tempted to put some pads under there. For instance, here are 3 rubber pads that are sold for this purpose, and without calculating the load on the pads or anything, we'll just put blocks of rubber under, as I've seen done in industry. Still pretty bad. We can try blocks of rubber. Rubber mounts are used quite a bit in automobiles, but they're normally mounted in shear and not in direct compression. And you'll note that the model is still creeping around. Now I'll try the 3 springs that have been designed especially for this mass and for this frequency, and I'll turn the motor on again, and as you cannot hear, it is not vibrating the table at all. One can barely feel the table. So I imagine that I've got a vibration efficiency, isolation efficiency of better than 90%. Now one thing that we should observe about this model, though, is that it has several extra modes of vibration. In effect, we've got a 6 degree of freedom system here, and although I've isolated the vibration vertically, I may still have some problems laterally. This is a problem in areas where there may be mild or severe earthquakes, in that sometimes it can shake a machine off of its base and destroy the machine, which is as serious as the problem we were trying to solve. The one way to get around this problem, one way that it's used by commercial mount manufacturers, is to build a mount that actually has a sleeve, and this has a rubber damping material, and then it has these piston-like semi-cylindrical pieces that gives this lateral stability, but without affecting the vertical motion. So this can have a low natural frequency in the vertical direction, but it will be protected from moving laterally. This particular model is made by Mason Industries, who's been in the vibration isolation business for many, many years. There are many other variations of this that can be purchased from other companies, but all this goes to show that vibration isolation requires a little bit of work and calculation.